Please welcome Melusine Reimers, Ruhr University, Bochum.
I'm Melusine Reimers. I'm the project manager of the Startup Center at Ruhr University in Bochum. We nominated GEMESYS because it is an exceptional AI startup working on one of the biggest technical challenges in AI. GEMESYS has developed a chip that works like the human brain, which makes it possible to democratize the use of AI. And GEMESYS should be the Falling Walls winner 2023 because the team not only has an excellent scientific background, but it has already received a historic funding of €3 million before its foundation.
Breaking the wall to brain-inspired AI hardware. Dennis Michaelis, GEMESYS.
Artificial intelligence is without a doubt the technology of the future. However, it has a big problem. Current AI hardware is too expensive to operate and inhibits innovation. Think of ChatGPT-4, which costs $100 million every month just to operate. Tesla has even created their own AI hardware and still takes them over a month to train their full self-driving AI. And that begs the question, why is the human brain so much better at intelligence? When you look at our hardware today, it is based on the concept between separation of memory and processor. And most of the time, energy is wasted on the communication between these two units. In the brain, however, both of these tasks are done by the same unit, by the synapses. And hence, the biggest bottleneck in our hardware doesn't even exist in the brain. At GEMESYS, we use novel electronic components called memristors in order to achieve the same effect in hardware and bring brain-like efficiency to AI chips with a potential improvement of 10,000x. This concept has been developed by my co-founder Enver and myself when we shared an office during our PhD time. Our founding team is completed by our management expert Moritz, and we have been very fortunate to hire a great engineering team with international expertise, both from the Netherlands and also from Harvard in the US. We also have a great team of business developers, and we are honored to have an awesome advisory board consisting of one of the co-founders of ARM, Jamie Urquhart, and one of the leading European experts in memristor technology, Professor Christian Wenger. Now, because our chip is so energy efficient, it will for the first time be possible to not only have powerful AI in data centers, but also in smart devices. And our grand vision is that every device will come with a GEMESYS AI chip. And once it is possible to both execute and train artificial intelligence on your local device, it opens a whole new blue ocean of new use cases. And that is because you have additional benefits like privacy. You can have sensitive data used to train your AI model because the data never leaves your device. Reliability, especially important in environments where you can't guarantee a cloud connection. And of course, low latency, which is for real-time critical applications very important, like autonomous driving and robotics. And lastly, bandwidth efficiency, because the more you are able to compute at the edge of the network, the less bandwidth you require. So what does our roadmap look like? Our fundamental benchmark is the human brain that possesses 10 to the power of 15 synapses. In 7 years from today, we want to be able to execute artificial intelligence on our hardware with the same complexity as the brain. And as the technology matures, we will be able to penetrate more and more markets along the way. Now, in the first, it is just for technical demonstration of our chips. But then already, once we scale, you come to use cases like energy, space, and medtech. When you scale further with the moderate complexity, you have autonomous driving and robotics. And of course, lastly, the most complex region is large language models. And I'm really, really proud to show you today that just 2 weeks ago, we were able to manufacture our first neurons and synapses in electronic hardware and confirmed that it's working. And so going from 0 to 1 in a fundamentally new computing concept is always the most difficult part. And now it's about scaling. Already before the end of next year, we will have a couple of hundreds of neurons and synapses working on there, and then already tens of thousands of neurons and synapses working before 2026. We are currently looking for a €5 million seed investment round to unlock the future of AI hardware. We have been very fortunate to have received grants from the German government of over 3 million euros and also been awarded several prizes with a total amount of prize money of over €500,000 as well. The next big milestones that we want to achieve with the seed funding are twofold. The first is a tech demonstrator as an integrated circuit chip, and second, a prototype of TRL level 6 in the space of energy, space, or medtech. Most of the money will be used to extend our engineering team, both hardware and software, with a single purpose: to make happen a chip that works like the human brain. Thank you very much, and I'm looking forward to your questions.
Great. I was making a picture of this thing which is as smart as the human brain, so to speak, right?
Yeah, sure.
Wow, that's impressive. Okay, let's go to the question with no further ado. So who would like to take it first? Jury? Yes? 2 here? 3 here? Okay. Please, go on.
Yes, thank you very much for your nice talk. Could you please explain a little bit about the costs in comparison with competitors?
Yes. So one of the great things is that when we designed our architecture, we made sure that the current maturity level of all components, and especially critical are the memristor ones, with the current state of the technology, it's enough for our technology. That gives us a whole benefit with regards to our competition. They require more maturity, we don't. And actually, there is not a single component that makes it more expensive than the chips that we have in our smartphones already today.
Okay, next question.
Yeah, could you speak a little bit more to the innovation at the heart of this? I mean, memristors are not new. It's
Yes.
the circuit architecture, and how have you validated it so far?
Yeah, very good question. So obviously, like also with like transistor technology in standard architectures, it's not the innovation is not about the individual component, but how you orchestrate like millions and millions of those components. And actually, you see that in currently there is like a huge exploration in the digital space. This is what the GPU of Google does, what the NVIDIA and TPU of Google does. Then you have some startups that try to put some of the operations into the analog domain. This is, for example, Mythic or Samron here in Germany. But we have found a way to completely transform the computation is purely analog, which gives like a huge performance boost. This is what we do here, and yeah. Yeah, we validate that as a software emulation, also now working as discrete components. This is obviously not an integrated chip. We will do that as our next milestone and have verified that it works, yes.
Mm-hmm. Who had the next question from the jury? I think it was Gitte, yeah? Please. Hold on, wait for the microphone. Here in the first row. Thank you.
Just the application, will the current neural networks run without changes on yours, on the training we've done for the same kind of models? I guess my question goes towards what are the trade-offs, the potential ones?
Yeah. The short answer is yes, they will work with the technology. But since we employ a learning rule that is much closer to how the brain works, we actually have the hope that you can have the same performance with models that are way less complex than they are right now. And so we hopefully are able to give like more complex use cases that are not suitable to run on very small chips. Nowadays, we will make them suitable for that. And actually, you can have the same models run there as well. But of course, we hope to improve on that.
Mm-hmm. First, we'll have a jury question here. Sorry for those waiting in the back. I know, I'm sorry.
Very naive question from an outsider. How does a memristor solve the problem you described at the beginning, the separation of storage and operation? How can that help?
Yeah. So essentially, what a memristor is like a resistor with a memory. And so basically, you could apply a certain input signal to an electrical circuit, and you get a certain response from the circuit, how it reacts to that input signal. But now, because the memristors, they do have a memory, when you apply the same signal, the next time the response will be different, because the memory has changed, because it remembers its past. And so this is exactly what you could argue is that the circuit has learned. Exactly what happens in the human brain, how synapses work, whether they strengthen or they weaken. And this is exactly what a memristor can do as well. Can have a higher resistance or lower resistance.
Okay, we have 17 seconds. If it's a yes, no question. Yes, Elizabeth? No, sorry, the microphone we need. Thank you.
Do you have any cooperations with industrial partners yet?
Yes, no?
Yes.
Thank you very much. And that's a wrap for that one.